derivatives with natural logarithms, chain rule, Lagrange's notation. So I'll separate these with when you're deriving a natural logarithm, which is just log to the base of e. It looks a bit like this: log to the base of e, which we replace with ln. You start with ln x. That's a simple example, and when you derive that, you end up with 1 over x. So the derivative, when you're deriving ln, you basically, whatever's in the brackets, you put under. So let's say if you had like 2x or x squared, you would derive that and you'd follow the chain rule to get the answer, and this is what I'm going to show you. So the chain rule in Lagrange's way is basically you have a function hx, which equals function gx within another function f of gx. When you derive hx, you end up with the derivative of f with respect to gx multiplied by the derivative of g with respect to x. And when you have hx, you have, and this is an example with a function within a function within a function, and this is how you do it down the bottom. This is how I've labeled them, just how I use them, how it makes it easier for me. You have derivative of hx equals the derivative of f with respect to g jx, the derivative of g with respect to jx, and the derivative of j with respect to x. So on that, let's get to some examples and learn how to do derivatives with natural logarithms. Chain rule way. So, example 1. Let's say hx equals ln x squared. So, we know if we have a function within a function, the inside function being gx and the outside function being f of gx, we can label them as such. We'll label gx as x squared, and we'll label f of gx as ln of gx. Because the gx we've replaced with x squared, so when we have a function with respect to gx, now we have a function with respect to gx, that being ln with respect to gx. Okay, so now we'll write the formula. Derivative of f, leave gx the same, multiplied by the derivative of gx. So we need to find derivative of gx and the derivative of f with respect to gx. Now, the derivative of x squared, just 2x. The derivative of ln with respect to gx is just 1 over gx. That is because if you would have ln with respect to x and you derived it, you would end up with 1 over x, just the same process. So, let's write this out. The derivative of h with respect to the derivative of f with respect to gx, 1 over gx, multiplied by the derivative of gx, which is 2x. So, to simplify this and make it neater in one step, we will bring the 2x on top, because it's multiplied, so it goes on top, and we will sub in gx, which is x squared. And that there is the first derivative of ln x squared. So, another example. Let's say hx is equal to ln of sine x. If you don't know how to do trigonometric derivatives, I have a video for that in the derivatives playlist. So, we have a function ln of sine x, and sine x being gx, so we'll label them. Gx is sine x, and f of gx is the same as ln of sine x. But because we rewrote sine x as gx, we just write f of gx as ln of gx. The derivative is written as such. The derivative of f with respect to gx multiplied by the derivative of gx. So, looking for the derivative of gx, and we're looking for the derivative of f with respect to gx. The derivative of sine x, cosine of x. The derivative of ln with respect to gx is 1 over gx. So if we sub these in, we get 1 over gx multiplied by cosine of x. So, simplify this and make it look neater in one step. We'll bring the cosine on top because it's multiplied. So we'll have cosine x over, what's gx? We'll sub that in, sine x. And that's your first derivative of ln sine x. This does equal something like tan x or sec x or cotangent, but I just can't remember at the moment. If you know your trigonometric functions better than I do at this moment, you could equal something x, which would make it look a lot neater. But I can't remember at this moment, so I'm going to leave it. You can do it if you want to. And so, let's say for the third example, let's hx equals sine ln x squared plus ex. Bit of there's a fair bit of shit in here, a fair bit of stuff, I should say. So you have x squared and plus ex, which is your first function, and then you have ln of x squared plus ex, and then you have sine of ln x squared plus ex. So if we rewrite this, the inside function, innermost function, I'll write as gx because we have 3, just like the formula I showed earlier. Jx will be x squared plus ex. G of jx will be ln of jx, and f of g jx, see if I can fit this in, will be sine of g jx. Close enough for me. So what we need when we're doing the derivative, well, I'll just write out this how I got that. My formula, I write it as f g jx. Jx being the innermost function, g being the second innermost, and f being the outermost. So the derivative of this will be derivative of f, while the inside stays the same, multiplied by the derivative of g, while the inside stays the same, multiplied by the derivative of j. So we need to find the derivative of j. Gets a bit messy the more you have, but this just shows you, this is just one example I'm showing you, I'm not going to be showing you plenty more. 2x plus ex. I have videos on trigonometric derivatives and derivatives with e. If you don't understand how to do them, I would recommend watching them, but just for this video I'll say that ex, when you derive it, you get ex. That's why I've got that there. Okay, so derivative of j with respect to g, derivative of g with respect to jx would be 1 over jx, because the derivative of ln of jx would be 1 over jx. and the derivative of f with respect to g, j, x would be cosine of g, j, x. So to bring this mess out, we'll write derivative of fx while leaving inside the same. It's cosine g, j, x multiplied by the derivative of g, leaving j the same, jx the same, of ln, 1 over jx multiplied by derivative of jx, which is 2x plus e to the power of x. So if we were to rearrange this and simplify, bring the 2x plus ex out the front. We put the cosine and put the gjx in. Gjx is ln of jx, so we put ln, and we'd sub in the jx, which is x squared plus ex. And then we put that all over jx, which is x squared plus e to the power of x. And that there is the first derivative of this function up here. I hope this helped. Thanks for watching.